Good morning or good afternoon, everyone. My name is Josh. I'm the head of the UQ SFP student chapter. Today, I'm very honored to have Professor Lovreglio. Excuse my Italian. I'm sure you can correct me. Joining us today. As I probably mentioned before, at UQ, human behavior is not something we actually do much. So it's actually quite a privilege to have a human behavior expert today presenting today on evacuation simulations from theories to modeling. Reno, as he is known by short, I believe, is a full professor in digital built environment at Massey University. He's a visiting professor with the School of Safety Science at Ting Shua University and a Rutherford Discovery Fellow with the Royal Society of New Zealand. He's published over 100 journal articles and been listed in the world's top 2% of scientists by Elsevier and Stanford since 2022. He's also an associate editor of the Safety Science Journal and Fire Technology with more than 500 submissions. And he's been awarded a 5 or under 35 award from the SFPE. Thank you very much for your time today, and over to you.
Thank you, Josh. I'm sharing my screen. I hope everything can see it. Perfect. Let's keep
Yes, all good.
starting. Thank you for the introduction. If you're wondering how to pronounce my full name, it's Ruggiero Lovreglio, but no one uses it since I left Italy because it's way too complicated. So everyone knows me as a Professor Rino, and it's more than enough for you to know. So I put together this presentation a bit reflecting on theories that we have been using in the field of evacuation and human behavior in fire, and try to show a bit of more connection of what we do to integrate them when we do evacuation simulation. As you might expect, this is just the tip of the iceberg. We have entire courses on human behavior and evacuation. I personally do also training with the companies in which I spend 1 or 2 days teaching all the evacuation stuff and all the software and workflow that you can use to integrate new technology. So today is just one of the little bite that you can get out of what I actually do when I do teaching. If you go and see my Wikipedia, you will soon realize that I'm Italian. That's why the name is so complicated and difficult to pronounce. And by training, I wasn't trained as a fire protection engineer. I used to be a structural engineer. I did a degree in civil engineering, and then my specialization in the master was about structural engineering. And through half of that master, I realized that something that I didn't want really to do, didn't click with me. So I decided to do something else. And that something else ended up being evacuation and human behavior study. And it was by chance that I discovered this topic in a workshop like this one we are doing today. I was not even aware that fire protection engineering exists or was evacuation modeling. I saw it in a few slides what it was about, and I said, that sounds like more interesting to me than shaking building. And from there, to be honest, it has been the journey of my life since 2011. And I've been doing my first research as a master, then PhD, then postdoc, and then all the path to professor. This is the 8th year that I'm in Mass University. I started a digital lab 18 years ago. And the reason I'm in the School of Built Environment is because they needed someone to teach BIM and new technology related with the construction industry. And because I've been using this technology quite a lot in all my research, it was relatively easy for me to say, yeah, I can do it. And since then, I've been with Massey. I started as a junior lecturer and then be promoted during the last 8 years to professor 2 years ago. Mentioned before, I work a lot behind the scene of peer review, and I do a lot of training also for a PhD and master student on how to write good papers and how to handle peer review process, which is a really key component if you're in academia. That's one of the reasons I go quite often to China to do this kind of talks. And since last year, I intentionally started doing YouTube stuff. I used to have YouTube for over 8, 9, probably over 12 years in my life, but never intentionally tried to become a YouTuber. From last year, my wife convinced me, the boss, to start doing more intentional work on YouTube to disseminate more about what I know. And to be honest, it became successful. From last month, we got the first paycheck from YouTube, not much, but you always wish that is more, but it's becoming a real journey. And I strongly suggest to get in touch with this YouTube channel because there is even a playlist on fire protection engineering where I put a lot of new stuff on workflow. And at the end of this presentation, I'm going to try to show you one of these workflow for evacuation modeling using Pathfinder. So if you're from a fire safety engineering background, you know that the standard things that we need to do from a performance-based design, try to figure it out if a building it's allowing us to evacuate all the people inside right in time before the condition became untenable. There are different ways to do it. There are different models, and evacuation model is one of and computer evacuation model are one of the elements in the equation that we use for the RSET. But before reaching there, of course, everyone can download an evacuation model, click few buttons, and make sure that it's up and running and looks like realistic. And yes, but what do we need to know before we set up those evacuation scenarios? So that's a bit of stuff that I'm gonna discuss today. So as you can see in this slide, there is a lot of theory, there is a lot of data, and then we need to try to connect the theory and data to the modeling exercise we are trying to do. So evacuation models are generally were born to support for design purpose of buildings, but there is a big overlapping between evacuation model and pedestrian dynamic tools. So if you remove pre-evacuation time and all the emergency side, you will soon realize that the same tools can roughly be a really good tool to use for crowd management to assess congestion during crowded events. So you might assume and you might expect that a lot of the tools like Pathfinder that are used and were born as a fire evacuation model today can be used for big events. And one of the upcoming events where I'm envisaging a lot of study done on crowds already will be the FIFA 2026. Of course, we have been using those models also for forensic analysis, and this is one of the key video that I would say is showing one of the major case study. This is the simulation of the evacuation of the station fire in the USA. It's a disaster in a discotheque that resonates quite a lot with the Crans, Montana fire that we saw at the beginning of this year in terms of all the things that could go wrong. And this is just one of the simulation done by the team of Ed Gallia showing how we could use, this is over 20 years ago, evacuation model and connecting them with the fire model to make good estimation of how many people will end up perishing in this disaster and try to identify other scenario like what if everyone was aware of this other exit and try to understand what could have gone better and what end up going really wrong. So I've been using evacuation model also myself to do dissemination. This is one of the top video that I publish on YouTube. It has reached nearly 90,000 visualization. And I did also follow-up video showing how Pathfinder could be used for recreate the bottleneck that we saw in the Crans Montana fire. So there is a lot of potential of this tool for educational purpose and go beyond what we do traditionally for protection engineering. So how people behave, that's the key question that we need to answer when we try to do evacuation modeling. And if you go around and you talk with average people, the answer is going to be always the same. People panic. And this is something that is belonging to all the education that we receive indirectly by Hollywood, movies, and misjudgment of what happened in disaster also by media. So people think that people are gonna start going crazy, doing really nasty things, pushing each other. In fact, it's the first things that you will read if you go and check media outlets. If you just do it today and try to figure it out, to retrieve information from the latest disaster that happened, you will see that you will find a lot of headlines with panic, panic, panic. But this is one of the videos that I put to explain to people that this is more a myth that is embedded in our culture and in our mind. And also, if you see this video with Professor Milad Agani from Melbourne University, you'll see that it's also part of what we have been telling people for safety preparedness. Like we tell them, don't panic in case of fire, just evacuate using the main fire exit. So if you really want to see why we shouldn't use panic and why we shouldn't use this concept to express, to define human behavior in the disaster, I really strongly suggest you to go to these two academic papers. Just in few lines, we need to avoid the use of the term of panic is because it's basically shifting the blame to the victims. You might say, people panic, they didn't know what they do, they end up not using the closest evacuation exit, they end up not responding right away, they start filming the stuff that was happening in the disaster with their smartphone, you name it. On the other side, you will see later on in a few slides that we can use a lot of theory and concept to clearly explain what actually happened during disaster and why people behave in a certain way. And it's not definitely panic the things that describe that. Of course, you can see situation in which, like in the station fire, you had a car crash at the main entrance, but the problem is way beyond before the car crash happened, way before people start pushing each other because they are fearing to be harmed by a fire. So there is a lot of things that can explain in a rational way from a victim point of view that can be misread and interpreted when media report or Hollywood try to make a movie out of a disaster. So if it's not panic that can help us explaining how people behave, and there is also a lot of scientific literature, especially from computer science, they use this concept. It's not true science. You need to actually go and see more social science work and people that work with more psychological lens to investigate what happened in disaster. You will see that there are different theories that have been proposed by social scientists that help us to explain the real behavior of people. One of the key model was proposed in the 80s by Cantor, and you can see that this image is a bit ugly because it's a photocopy that I managed to do of this book on human behavior in fire that I managed to find it the first time in Sweden for the first time in my life. I never managed to find it physically and intentionally make a copy. And you can see that the process that people can go through when there is a fire can be much more complicated. It's not that people don't do nothing and then they decide to evacuate straight away. There are many other things that they do. They do investigation, they need to figure it out what's going on. And based on this information that they have, they might need to explore or decide to withdraw and say, no, probably it's nothing real happening, or collect more information, decide to fight a fire, especially if they are trained to use a fire extinguisher. But many times you will see in video people that have no clue how to use a fire extinguisher try to use it and most likely harm themselves and others, especially when the fire is way beyond the control of a single fire extinguisher. So there is a lot of things. But when we do evacuation modeling, we generally switch from do nothing, evacuating. But the behavior can be much more complicated. And what is actually driving the behavior of people and the need to respond to a fire is a key component, and it's risk perception. Risk perception is something that is used quite a lot to explain why people do certain things instead of other, and when people eventually start evacuating. And this is a model that was proposed actually in many other disasters beyond evacuation in buildings. It was proposed by Lindell and Perry for describing behavior in hurricane, tornado, and major other disaster. And still, it's a really good model that can help us to really put a lens of how people internalize all the cues that can be physical cue, social cue, and then make an answer, make a response to what is the situation they are facing on. A really good simplification from an engineering point of view was the model proposed by Renick in 2013. I love that paper. It's a NIST report that basically try to convert in an engineering way how people internalize all these cue and they transform it in a level of risk perception. This is an image that I created in my paper in which I try to calibrate this model, and it give you a simple understanding that based on what are the stimuli that you receive, you will see that the risk perception might go up and down. It depends on what you perceive. And eventually, if we cover a specific threshold, then people will feel unsafe enough to start evacuating. But if you see and you think through regulation and what we do in evacuation model, we actually use it, this concept, but it's basically hidden behind the scene. Risk perception can definitely help us to explain a lot of behavior that might not make any sense if you know what happened in a disaster and then you watch from a couch what was unveiling out of a real disaster. In this case, the fact that we saw, for instance, in the Crans Montana, teenagers, really young kids, taking video of the fire is not related to madness. It's related to a really low risk perception and misjudgment of what was about to unfold. Because, of course, in many buildings, you don't have fire protection engineers that have been in many experiments. Let's see what happens if we ignite a foam on acoustic panel and how fast it's gonna spread through all the building. So you can see like behavior of recording what's happening in a fire, or the fact that people evacuate from flights always carrying their suitcase. Is always a matter of underestimating what is the real threat that you might end up facing if you delay your evacuation to collect your belongings. And it's something that we keep seeing more and more. That's why we need to refocus quite a lot of what we do with safety training to tell people, not just don't panic. Make sure that you do A, B, C, and look how much time you will have in case there is a fire. It's not like a lottery of 10 minutes evacuation out of a building. Sometimes we have seen in major disaster that the time will be 60, 90 seconds. Affiliative theory is another good theory that we use to describe human behavior, and it tells us that people end up going with evacuating through using the most familiar exit. So although in many evacuation scheme, you will see, we have an evacuation here, door here, 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 here. You might expect that most of the people might end up using main exit, unless you have people inside the building redirect people towards the closest exit. Unless there is a real strong cue, like someone inside the scene, you will see that you might expect that many people will end up using the main exit. And another things, why it's important of people that are inside the scene to give instruction, because if someone has an authority before a fire, like a teacher or a building manager, it will be listened much more harder by people. We have done also experiments showing that if there is an instructor telling person, please go this way, it can really have a huge difference on what people will end up choosing during the evacuation. And if you see here, this is a picture of the station fire, and the road rule model play a key part in the pre-evacuation stage of this fire, because the band, until 20-30 seconds from the ignition of the fire, were still on the stage performing. The music was still there, and they were basically the role for the rest of the patrons. So no one started evacuating until they decide, okay, that's enough, we need to get out of them. So you can understand that, especially in some situation, few quick responses of key people might have a dramatic difference of what will be the outcome of a disaster. And of course, the other things we saw in the same fire, the station fire, is that, as we mentioned before, many people end up using the main entrance. And beside the reason there was a crowd crash because all the configuration of this lobby area right here, you will see that many people got stuck here and end up perishing in this area while trying to evacuating from the main exit. In this case, then, if you read the report, you will see that those windows got broken, and then people start evacuating also from this window after the crowd crash happened in this area. So once again, it's something that we are well aware, and we need to make sure whenever we do design to make sure that we don't put stuff that impair the evacuation, especially if we are talking about the main pathway to escape and to get in and out that people are familiar with. Social influence, of course, play another key impact. We are affected by other evacuees in an environment, and we have two types of social influence. We talk about normative social influence is what you will experience when there is an alarm going off and everyone is feel awkward. They don't want to start evacuating because they want to belong to the norm that everyone is not doing nothing. So it's better if I don't start doing anything else or look foolish by trying to evacuate and by look like the loser in the scene. Informative social influence instead is what we use to understand what is an available exit, for instance. If you see many people using an exit, you might understand, oh, that's a clear way out. And if you see another evacuation exit not used by anyone else, you must start thinking, probably no one is using that exit. It might be that that exit is the only way out. So we can start inferring a decision, a clue, and make our decision based on what other people do in evacuation. And the reality is that we are somewhere here and now. We are in the position in this historical period of fire protection engineering, which there is the fire protection engineer that needs to define scenario and the action of this evacuee in an evacuation model. The ideal thing will be that in the future we will be capable to have just the setup of the scenario and then smart evacuation model that are capable to have agents that actually behave like real humans and end up mimic their behavior. Are we close to that? We are still years, miles away from this achievement. And part of my work has been try to increase the smartness of evacuation agents. But you will see soon that we use pretty simplistic assumption when we do evacuation modeling to integrate what we've been talking in terms of theories. So, because there is a lot of input required by the engineers, that means that really bad assumption, really bad input set in evacuation model can end up in a really unrealistic results from the evacuation model. And the problem is that the people, especially the one outside the field, might see a model that looks like realistic because the agent looked like a real human walking a space. But if you go and deep dive into the details behind this model, you will see that most of them are relatively simple, and the key results might depend by the key input that we put in these evacuation models. This is just an example of what we do for a pre-evacuation. We know that in theory we could model it by try to assign to every agent a risk perception and then try to understand based on the risk perception what is the likelihood that an agent is going to evacuate because it's close enough to the fire or it looks at something similar about someone else evacuating already from the scene. Instead, when we do pre-evacuation in a standard evacuation model, we end up using a pre-evacuation distribution. We then use random generator number that assign pre-evacuation time out of this distribution to agents. And then as the time click, you will see them from standing idle in a place like idiots, they will start getting out of the building one by one. And of course, in this case, you can start play around to make some assumption about distribution of groups that start evacuating together or not. And you'll see that some existing code try to embed the theory that we were talking about, and especially risk perception. And you see that this is just some sentence that I took from the CVM2, one of the code in New Zealand on our building code. You'll see that depending, if you go to the tables of pre-evacuation time, you will see that the pre-evacuation time might change depending of the person is close to the origin of the fire or not. And it's basically what we roughly try to do is to make the assumption that whoever is close to the origin fire is going to have a higher risk perception and so start evacuating much quicker than the people that are away from the place of origin, in which you might expect that they might be affected by observing other people evacuating, the one that were closer, or other fire alarm system. And of course, the clarity of the queue that we have might have impact on the response time. There are experiments that have been testing them, and this is now also in standard like the CVM2. In fact, the type of alarm might reduce the time required for a person to make a decision to evacuate, especially if you use a voice system. But also in that case, there is a can of worms that we can open. It depends on what you put in the voice system. And it depends also from who is in the building and how much are familiar with the language that is used by this voice system. And also the focus of the participant. This is another thing that is interesting from the CVN2. You will see that in that case, the pre-evacuation time is 0, but it's still a design requirement. It doesn't really reflect the reality, because if we see the station fire, although there was full focus on what was happening, the fire was in front of everyone because it was on the stage. People didn't start evacuating until 20-30 seconds when the band decided it's time to get out. So codes are always like try to find a balance between what we need to do to have something built and the real behavior of what you might expect in a real disaster. And of course, the perception of queue and the risk perception can be affected, of course, on the fact that someone is sleeping, intoxicated, and stuff like that. Because if we have a cognition system in our brain that is not working for 100%, like in a normal situation, you may expect that it will take much longer to have an evacuation. Where can we find the evacuation distribution? Well, I would love to say go to the SFPN book, but in reality, there is not much of evacuation distribution there. A really good place to go is this paper that I published when I was NIST working with Erika Kuligowski. And in this case, we managed to retrieve all the existing data on distribution, and we managed to create cluster of pre-evacuation distribution, try to create a distribution that could be used for any kind of building. But of course, in that case, you need to find a distribution that might fit better what is the design scenario that you are trying to take into account. And another thing that has been a big research question for everyone and a bit of a headache for anyone that was trying to do evacuation or simulation for a hospital was the preparation time. This is another kind of worm that no one touched for years. And last year we were really proud to publish one of these first paper in which we analyze a lot of pre-evacuation times and preparation time in different hospitals here in New Zealand. And we managed to provide an estimation on how long it will take for people to evacuate. And you will see that if you go to ICU unit, it might take really long amount of time, no matter you have 3 or 4 people try to unplug a patient. So it really depends on the machinery, it really depends on many people are acting to prepare a patient. What about exit choice? If you use standard model, you will see that many exit choice, basic exit choice assumption made the evacuee going to the closest exit. So basically they estimate the shortest path, and then you have the evacuee running through the shortest path. But we already mentioned that this is not real the case, because there is much more affecting the behavior. We have also the possibility in this model to have a probabilistic assumption. So you can say 80% of the participant might end up using the main exit. The other 20% and then going to end up using different exits. So we can make assumption using probabilities, but we can also go beyond this simplistic approach. We can also start thinking about model, and we have been developing and proposing different model on this line, assessing how many what will be the probability of person to choose an exit rather than another one. How can we make this estimation? We have been analyzing a lot of evacuation experiment and a lot of even virtual reality experiment in which we put people in different layout, in different distance from the exit, and different condition like, different condition in which we change the location of the people, and we start putting a cue like smoke coming out of an exit, or different other people already using this exit, and try to ask people which exit you will choose. So based on this data, we have now evacuation model, exit choice model that can be used within evacuation model that allow us to do real-time assessment of the situation and have smart agents that can choose the exit based on what a human will do in a similar situation. From a navigation point of view, I will say that probably this is not one of the major headaches that we have to go through. There is a lot of stuff that has been proposed, and from a macroscopic point of view, the fluidodynamic model that you will see in the SFPN book has been one of the most popular to have a hands calculation with just a piece of paper. You can assume that people behave like a fluid. You have a flow rate from an exit. You make some assumption about evacuation. Just with a piece of paper or with Excel, you can make an estimation of how long it will take to evacuate a specific environment. But then there's been a huge exponential growth of computer evacuation model in the last 20, 30 years. And they are based on continuous assumption. And back in the day, we used to have discrete models that are working like a chessboard in which the agents will be capable to move from one cell to another cell. I must say that these models are becoming less and less popular, because back in the day, the only reason behind the scene was because it was extremely computationally demanding to have a continuous model. But with the computer and the hardware that we have now, using social force model or steering model is not any longer a big issue. In fact, with Pathfinder, you can have tens of thousands of evacuee run on a single laptop. And this was basically impossible back in the day when I started doing evacuation model. And for tens of thousands, it would have been probably only possible using cellular automated model. The world has been shifting from a technology point of view. And of course, they were also mesoscopic model proposed back in the day, try to find a compromise when there are too many evacuee between the place where we don't really care to be detailed about what's happening in this corridor. We know that the flow rate will be roughly this one, and we go and use instead the microscopic model when there is a bottleneck to analyze what's happening on specific critical places. So if you want to go and see the hydraulic model, you can go to the last version of the SFPN book, And you will see in chapter 59, you will see the standard equation that you will see also implemented in Pathfinder, in which you see that basically the relationship between speed of people and density, it's at the beginning constant, because with low density you don't have any impact on the speed of person. It's basically an unconstrained speed. And you will see that after a specific level of density, you may expect people going and slowing down. But is it this a real phenomenon? In reality, no, because we know that we can reach higher density. And you'll see that also with higher density, you have stop and go phenomenon, in which you will still have flow rate, no matter the density is much higher than 0.5 or 0.6. Another type of fundamental diagrams that are slightly different from the one proposed by the SFP handbook are the one that were proposed by the Russian Predelinsky and Milinsky. In this case, it's all works in terms of interpersonal distance. So we stop using the concept of density, that is more engineering way to measure stuff in a crowd situation, and we start using instead interpersonal distance and relationship between speed and interpersonal distance. You will see something like this and more about this stuff in the new version of the SFPM book. Hopefully it's going to be out this year. And in this case, you will see something that basically give you more insight of an alternative way to what we used to use with the previous version of the SFP handbook. And if you go and see, there is quite a lot of new data that have been generated related to fundamental diagrams. So you can see that the SFPN book curves is basically an approximation, is a design curve. It doesn't really represent the reality. And a place where I suggest people to go if you want to see one of the latest review on all these pre-evacuation, all these movement data is this literature review from ETH. And you can see that there's been an explosion of studies observing how people behave and move on different crowd situation, in different kind of building, in different context, with different participants and stuff like that. And from evacuation point of view, if you want to go and start using evacuation model, of course, there is a lot of there. This is a collection of video that I did when I was still a PhD in Sweden in 2015. And it's just an example of pre-evacuation model. This is Pathfinder. It was used by my supervisor, Enrico, to do evacuation of schools. So you can see here, you can simulate the evacuation of an entire group, in this case, as a classroom evacuating all together. You can have Pathfinder, once again, let's go. We can have also computer engine like Unity that can allow you to do evacuation simulation today. This is another example done by Rico using steps. And this was my first evacuation model ever. It's called EVAC, and it was within FDS. But unfortunately, since 2-3 years ago, it got kicked out from FDS because there wasn't no one, unfortunately, in Finland to maintain that code. But it has been, to be honest, the evacuation model that I start using to learn the basic of evacuation. So I left intentionally the last minutes of our presentation just to give you a bit of overview of different workflow that you can use in your models. This is a workflow that I published on my YouTube channel probably 4, 5, 6 months ago, and has been already watched thousands of times. And I want to quickly show you how quickly it's now possible to set up an evacuation simulation, starting from a simple PDF document. So assuming that you receive a PDF document, there is not even a build information model that allow you to do the simulation. How quickly we can set up an evacuation. So I'm going to show you that I can do it in front of you within a few minutes. So there are different workflows, of course, that you can use. And the things that I found mind-blowing last year is the discovery of this web application that is an AI-driven application that is capable to do segmentation and annotation of PDF and try to figure it out where are walls and doors and generate an IFC document. IFC it's basically a standard document that is for OpenBIM. So it's something that you can open and read as a text, is a set of text of file. And I'm gonna quickly show how we can integrate all this stuff within Pathfinder and create an evacuation simulation within a few seconds. So I have already Pathfinder open here. And the other tool that I wanted to show you is this one. It's Amplify. Let me instead copy and paste in the chat in case you're wondering where you can find those videos. You can do by going to my YouTube channel. So in this case, I'm gonna just load now one of the PDF that I already put for the UQ demo. Let me go and open this PDF in front of you so you can get a sense of what is inside this PDF. How many? Too many windows on this when Zoom is open. All right, let's open it with Firefox. All right. So I'm going to show you that in this case, I intentionally use something relatively simple.
I'm not sure if we can see the Firefox.
I'm about to put it
Okay.
on the other screen. It was basically doing all the naughty stuff on the other side. So I'm going to basically use this file something that I just downloaded from the internet. I was looking for 4 plans in which there are different apartments. And let's try to open this one, this 2-bedroom apartment with a garage, 2 evacuation exit, 1 and 2, but it can be anything that is a PDF document. So let's go and open this file. And you can see that it's already identifying that there are different floor plans and is making the assumption that they belong to the same building at different floors. In this case, it's not the case. I'm gonna delete all the floors that they are not actually floor and focus just on this specific file. So let's go and start. You can see in real time the BIM version of this PDF has been already created with all the IFC. The key IFC element that you need to have for this is gonna be IFC slab, IFC doors, IFC windows, and you can see also the room, IFC elements. So now we can also go and exported it. In this case, I've already put all my information. They didn't charge me anything. And I agree with the condition and download the IFC documents. And if I go in my folder, working folder, you can see that the IFC document look like this. And if you never open IFC documents, you can just use a notepad tool and you'll see the metrics behind an IFC documentation. So this is what is an FC file. It's a bunch of lines that codify all the information of a building in a standard open format. And the good things about having open format compared with having a Revit format is that everyone then can use it as an input for their evacuation tools. In this case, what I'm gonna do is just to go to Pathfinder and import the IFC document. So you can see here is already allowing me, is capable to see IFC documentation. The things that you need to be careful here is to make sure that you use the right information in terms of scale, millimeter or meter. You will see in many cases that people change these, for instance, to meters while the file is in millimeter, and then the door look like tiny, like they look like a fraction of a centimeter. So if you put all this information in the right way, you can see that that PDF that was unusable a few seconds ago, let me hide this part, has been converted into an IFC document, and now the IFC document is already within Pathfinder. How quick is now to use this document and create an evacuation floor for Pathfinder? You might feel like you now need to go and do the drawing one by one. In reality, there is already a generate model from this selection. So once you just do right click, generate from BIM, you can see that we have already something ready to go. And to see it, we can just hide all the BIM stuff. And you can see that this is already the floor plan of Pathfinder, ready and good to go. Do we need the geometry? Nah, it's just if you want to have something fancy in your visualization. Now we know that the evacuation exit were here and here. So the only things that we need to do is to go and select the door tool. In this case, the door, it's 0.8. I can expand it. I can even put a crazy number. Let's put 150. And you will see that the tool is pretty smart, that is not going to allow you to put something bigger. It's reaching the limits of this slab. And the same things, we can start now putting an exit here, give it really a reasonable number, and it's good to go. So now we can go and just put the information about the agents. We can put bunch of agents here, bunch of agents in this area. And of course, then in Pathfinder, you have the possibility to add all the information about pre-evacuation times, behavior, what are the key components. Let's go from the top view to use. The two components to use are profiles and behavior. Let's assume, for instance, that I want to put a pre-evacuation behavior for these agents. I'm gonna generate a new behavior. Let's call it behavior UQ. We start selecting it, and then we can start, oops, where is it? We select it, and then we can start adding action. So you can see here, wait action. We can use a uniform distribution from 10 to 20 seconds. So we have already generated a simple behavior that is going to have people with a pre-evacuation distribution from 10 to 20 seconds, and then reach any exit. In this case, you can even set up and decide yourself which exit you want to use. And in my case, I always suggest people to be also mindful on the fact that people might end up using the familiar exit. In this case, it's an apartment, doesn't really apply. Otherwise, I could have gone here and say, I'm pretty sure that these people will end up using the door number 01. That is this one. So in this case, otherwise, they will end up using, of course, the closest one. So let's go and see how we can assign this behavior to this group. We select the group and we say, okay, the behavior that this group is going to have is the UQ behavior. And bam, we are really good to go. I can now save a file, and within less than 10 minutes, I show you how quickly, if you know to use really good workflow, you can end up passing from a simple PDF file, useless, to an evacuation simulation that looks like this. So when I show evacuation simulation using Pathfinder, people get really excited, especially from the industry, that they have no clue about evacuation model, because they look real, these agents. So they believe that the behavior of these people is real. you need always to explain that the fact that the rendering look realistic doesn't mean that the behavior can be realistic or not. As you can see, the behavior that these people are using are strongly affected by what I told them to do. And there are a lot of many other features within Pathfinder that you can use. And if you stay in touch with my YouTube channel, you will see that at the end of this week, I'm going to release a new video on an evacuation tool that requires zero installation and it's all free. So it's something that has been developed in Germany, and I'm about to make a video to show this other alternative in case you don't want to pay the fees for Pathfinder. There is this alternative that works also with IFC documentation. It does a lot of basic stuff. It doesn't have yet stairs, so if you need to simulate a multiple floor, it's still a pain in the ass, but you will see later this week this other video. And as I mentioned, this is the place where you can go. I have a full playlist on workflow showing how to use BIM into Pathfinder, a lot of video on how to use BIM in Blender and use BFDS, that is Blender plus FDS, if in case you don't want to use Pyrosim and you want to do everything for free. There is also that other beautiful tool. And as I mentioned, I do a lot of training for the industry. This year I was, for instance, in Singapore for a couple of days to do training about artificial intelligence and all the BIM workflow that you can use in the industry right away using just some basic knowledge behind before understanding what is BIM and how it can be integrated in many other workflow and allow integration and automation. So I think I managed to keep some minutes available for us for some question.
Yes, thank you very much for that very insightful presentation, Reno. We really appreciate it. There's already two questions in the chat from
All right.
James and Meng Fang. But yeah, if you have any other questions, feel free to put them in the chat or even just unmute your microphone.
With heavily annotated drawing. I've been tried it with other more annotated things. It seems to work. The other good thing is that even if we overdo and sometimes it overdoes creating more walls, you can always in Pathfinder or Pyrosim deactivate those elements or delete this element. So it's not 100% perfect model, but it does 80-90%, in this case 100% of the job. That it works for Pyrosim and FDS modeling? Of course, yes. And I have a video once again in my YouTube channel. That's why go to my YouTube channel and you'll see if we go to the playlist, there is a playlist on fire protection engineering where there is a bit of science. Hello, everyone. There is a bit of science, but there is also stuff. Let's go to the video. It's easier probably to go and see that from there. So there is a workflow that I posted 5 months ago that is showing similar workflow using Amplify and go through all the steps that you need to go to move to Pyrosim. What if you don't have Pyrosim and you want to use FDS straight away because you don't have the license and you don't want to pay? PAM, this is the other workflow that I put together in which I show how you can use Blender and import IFC documentation within Blender using Bonsai and then do the conversion in FDS format using BFDS. And you can see that there is a lot of video on BFDS because it's one of the really powerful tools that allow to do a lot of sketching of FDS simulation without doing writing any line of code. Let me see the other. And of course, it can be applied to any kind of infrastructure, even road tunnels. Wildfire scenario. Wildfire scenario is another kind of worms that we are slowly getting there. I am aware that there are platforms that allow you to do evacuation of big area. In that case, I wouldn't expect to use a pedestrian dynamic model. One of the most customizable application that you can use is Sumo. It's a free open platform that allow you to do traffic simulation, but there is a lot of work to be done to set up an wildfire evacuation scenario. There is also a platform that has been developed in the last years by colleagues from Sweden and Australia, Unity, but I don't know if it's available to the wide public yet. So it's, and even if you have, to be honest, a model up and running and set up straight away, there is a lot of uncertainty that we still have in terms of how long it will take for people to start evacuating their home. It's much more complex and dynamic than just using a building evacuation model. It's next level of uncertainty that you need to account for, and even where people are gonna go during this disaster. There is a lot of stuff that we basically still try to investigate, and we have been doing a lot of research in the last. We have been doing a lot of research in the last year using GPS data to figure it out when people leave, where they go, because they are all key information that you need to have in mind, and when you need to run a evacuation simulation of large scale like a wildfire. Thank you for the positive comment of excellent presentation, informative. I hope you find it useful. As I mentioned before, this is just a tip of the iceberg. Generally, I get paid to speak a couple of days on this kind of topics. Today is just to give you a bit of sense of where we are in terms of theory, and the theory are not basically new. It's something that we knew for already 20, 30 years. But in terms of automation, there is a lot of new stuff that is coming up. And what I'm trying to do in my weekends is try to figure it out, new tools that can be integrated with evacuation or fire model, BIM stuff that can be used for all this kind of automation. A good reference to start an evacuation modeling. The student that asked me this question get always redirected to the SFPN book. There are really good chapter where you can find, at least in the old version, the chapter of Erika Kuligowski on the human behavior theory and what we know from all the behavioral study that we have done. And then there is a lot of good stuff in the evacuation modeling chapter. And there is so much that you can go. It depends on which pathway you want to end up working on. But I would say that these two chapters is the starting place. Then, of course, I will recommend you to read the paper written on evacuation limits and panic. There is quite a lot. If you send me an email, I can probably direct you to many other links. But roughly the stuff that we already introduced in this video we have been discussing is a good starting point if you want to start from zero.
I actually had a quick question for you, Reno.
Yeah.
I guess lots of these models, anyone who's untrained potentially can start a pyrosim, sorry, not pyrosim, Pathfinder model, and press run and get some results. And because it looks realistic, it looks great. So what sort of tips and tricks do you have, I guess, for people who are reviewing models or reviewing their own work to sort of say, okay, this actually doesn't look right. Maybe I need to dig deeper and
Yeah, the
um,
devil is always in the details of the, like in FDS, you will know where people can cheat. Suit yield, CO yield,
yeah.
you can make things, make it look much more beautiful. In a evacuation model, the things that really dramatically can affect are pre-evacuation time and the flow rates of the door. You can make assumption of the flow rates that are way bigger than what you can actually expect and show, look, there is no congestion, people evacuate smoothly. And the other things that it's always challenging the evacuation design is people going to the main exit. So all the things that we mentioned today, if you make the assumption everyone is going to use the closest exit, the pre-evacuation time is only 10-20 seconds. And you go and see that in the literature, that's not the case. It can be a case of 20, 30, 40 seconds when it's a disco nightclub fire. But if you have a residential building and you're trying to have a simulation nighttime, it might take 5-10 minutes for people to start evacuating from their house. So you can go and see all these kind of details of where people go, when they start evacuating, their speed, if there are accounting for impairments, because if you have someone with impairments, the evacuation speed can drop from 1.25 meter per second to even 0.4 meter per second, especially in retirement homes. So you can quickly grasp if there is someone that assumes that everyone is an athlete in this scenario and everyone is gonna run smoothly.
Excellent.
I have a question. How to train someone to fight the fire or what do you mean to train? To train humans or to train an agent? I don't understand. I If you can write down about the training on firefighting or evacuating. I don't know if you're referring to buildings like a real situation or a simulation situation. If there is a global standard and evacuation, yeah, there is a global standard about evacuation. There are some ISO documentation, and the ISO documentation, the other old stuff that I used to refer to when I was doing my PhD and master was the British standard. And if you see, there is the CVM2, the standard in New Zealand is basically an oversimplification probably of the British standards. But there is quite a lot of behind the scene that is happening, and there is also working committee on in the ISO working on implementing more BIM, implementing and integrating more BIM into the evacuation workflow. For how can decide this is something that you need to make a desk. Okay. Regarding the simulation, you have the possibility potentially to have people try to extinguish a fire, and this is something that you can assume that it's the behavior that you might have for someone that is staff in the building. You can set up action for agents and try to show that they are going close to the place of fire, wait there for 20 seconds, and then start evacuating. It depends on what you really want to simulate. If it's something that try to recreate what happened in a real disaster, or if you're trying to do a design experiment, and it depends on the code regulation. Like if you go and see the Singaporean code, it give you some strict regulation on many people are going to end up using the main exit, and they might have also some other challenging scenario that might enter into their code in this year or the coming year. It really depends on the context. Have you tested Pathfinder capability coupled with Pyrosim? Not yet. It's only on post-processing at this stage. I haven't tried it myself, and but it seems like from the release that I saw a few weeks or months ago, it's relatively easy to connect and do a really good quick estimation of the FID for each agents. Unfortunately, back in the day, we used to have an evacuation model like evac that was doing it by default, and it was also reading in real time the visibility and reduce the evacuation speed of people based on the visibility. This is something that you need to reiterate in Pathfinder because you need to see the visibility and then set up, reduce the speed after a specific amount of time. So it's something that I know they are working on the coupling, but it's not there yet. A software that does it and has been doing it for years as well was Exodus, the software developed by the Greenwich University, and it's a really good other document place to go if you really want to have a really strong coupling between fire and evacuation model.
I have a quick question, Reno.
Please.
So sorry, I'll just turn my camera on as well.
That's
So
right.
The other day I was trying to do at work, trying to do fire modeling escape in Pathfinder, and correct me if I'm wrong, but my understanding is basically the way that you can program behaviors is all based on, if you want to think of it like magnets. So the doors pull people towards the doors. If you set a waypoint, it pulls people towards the waypoint.
Yeah.
In this particular scenario, I I had set all my parameters and all the behaviors and everything,
Yeah.
but still the agents were choosing to walk directly past the fire, and I couldn't find any sort of setting or behavior or something to sort of push them away and
I
yeah, keep them
don't
away from that
believe that
fire
they have
base.
anything set up on that at this stage.
Okay.
The only things that will try to create is a set of waypoints. So
Yeah.
you
Okay.
basically recreate the place where you want them to do. And to be honest, sometimes even in Pathfinder, if you use the standard exit choice model behind the scene, you will wind up seeing things that don't really make sense to me.
Yeah.
And most of the time, what I do is to put some walls, fictitious wall, that force people to go not into a specific area. And it's
Yeah.
something that I actually had to do. Let me go. When I did this simulation here for the Crans Montana fire, without, let me go and see. So in this case, to make sure that no people were passing through the fire from this area and start using this area, you see this line here, this black line here. It's me enforcing formation of tree. It's me enforcing a wall to
Yeah.
make sure that there was no one passing through the fire. And also in that case, when I did instead the simulation, which I opened this exit, I was observing really bizarre behavior of someone that he was right here, and he was trying to, while everyone was going up, he was trying to go down to use this exit. So in that case, what I did is my adjustment using common sense and say, no, if you're here, you're most likely that you're gonna follow the floor. You're never gonna end up downstairs unless you're staff or you have a really strong motivation to do it. So in that case, I had to set up manually this bunch of people to go to this exit. Otherwise, I was observing really bizarre stuff. And
Yeah.
this is where the engineer needs to end up putting his hands, because we can't just set them the scenario and assume everything is gonna go perfectly. You
Yeah.
need to start making some more strong cutting here and there to make sure that the simulation actually represents something that makes sense.
Yeah, my workaround that I ended up doing was setting up obstacles with increasing resistance, basically. So the closer that they got to the fire, the less they actually wanted to go in that
Yeah,
direction.
that's another alternative that
Yeah.
you can use.
Yeah.
It's a bit of like a bit of like, as much you know the tools and try to recycle what is in there to replicate what you really want to do.
Yeah.
They are really customizable, thank goodness, now this software. When I was using Pathfinder 10 years ago, it was like already beautiful to have something that looked realistic, but it was extremely simplified. And I hope that the next step for them will be to do more work on coupling. But it's an active group. I know that they're always trying to implement. In fact, in every release, you see that there is always something new. So it's just a matter of time. I know it's in their to-do list. He has been in their to-do list for so long, and hopefully we will soon have automatically fed calculation, automatically slow down and change of exit in case of different visibility of fire and stuff like that. But yeah,
Well, thanks for your time, Reno.
don't worry.
All right. I think I might wrap it up there, given we're 10 past the hour. But thank you very much for your time, Reno. We really appreciate it. And thank you, everyone online, for attending.
And yeah, if you have any question, don't forget to reach out. I'm easy to find on LinkedIn, Facebook, Instagram, wherever. And please stay in touch with the YouTube channel, because, as I say, on Friday, Saturday, I'm going to release a really cool video on evacuation modeling, and it's going to be for free.
Sounds good. I will also upload this video to our UQ SFP student chapter if you want to watch it again. Yeah, so thanks everyone for your time, and see you next time.
Bye-bye.